So we're continuing looking at this exponential decay function. We're trying to write out what the function is if we're given the graph. We found our asymptote was at -4, so our k value, our y shift, is at -4. The point closest to the asymptote is telling us that our h value is 1. We've shifted to the right 1. So we'll use the other reference point here, which is at 0, 4. We'll use that second. We need to finish with that first reference point to find our value of a. So our a plus k will be -2. Well, our k value is -4. So adding 4, our a value is 2. Now we use that second reference point. This one's going to be a over b plus k is equal to that y value, which is 4. So we'll have 2 over b minus 4 equals 4, which means 2 over b equals 8. And then b will end up being 1/4. Sorry, b will be 4. So the fraction of the base will be 1/4. B is the denominator. So taking what we have, our function g of x is equal to our a value 2, our base, which is 1/4, x minus 1, and then minus 4. So our domain still be all real numbers. Range, we'd say y is greater than -4. So doing some modeling, an exponential decay function has the form f of t is equal to a times 1 minus r to the t. So this is essentially the same as the growth, except instead of 1 plus r, it's going to be 1 minus r because our values are now decreasing. So for example, here we've got a truck purchased for $28,000, decreases by 9.5% per year. So our a value is 28,000, and then we'll have 1 minus r, so 1 minus 0.095 to the t. So they're showing how to find these values and mess with your calculator to solve the problem that they're working on. Here we have the value of a sports car purchased new for $45,000, decreases by 15% per year. So our a value is 45,000, our rate is 0.15. So plugging those in, we started at 45,000. 1 minus 0.5, and 1 minus 0.5 would be 0.85. So that's our function, 45,000 times 0.85 to the t. So we want to add this plot to the graph of the truck value from example A and find the intersection of the two functions to determine when the values are the same. So if you plug in both of those functions and change your window size, you'll end up with 7.567 and then 13,155 for your values here. So that means after about 7.5 years, the truck values would be the same at 13,155. So then we're just going to try one more of these on our own together before we call it the end. So on federal income tax returns, self-employed people can depreciate the value of business equipment. Suppose a computer valued at $27.65 depreciates at a rate of 30% per year. So our a value, $27.65, our rate is 0.3. So our function would be our initial value, and then 1 minus the rate. So 1 minus 0.3 is 0.7 to the t. And then we're trying to find out when is our function equal to $350. We want to see when it's worth that. So we'll have to go back to our graphing calculator here. So if we want to graph our function, so 2765 times 0.85, to the x. And then we want to see when that's equal to 350. So our x values, we'll set it back between 0 and 10. Our y values. So obviously we're trying to see when is our y value 350. So I'm just going to pick between 300 and 400 at intervals of 10, just because I know that's where I'm looking. I want to know when it's 350. So we're not going to get to see the whole function. What happened? Oh, 2765. Let's see, because I know what the answer is supposed to be. And, oh, you know what? I put in the wrong value. I put in from the last problem. This should be 0.70. Sorry about that. Now, hopefully it will show up. There it is. We don't see the whole thing, but we don't need to. We just want to see when it's equal to 350. So since we've drawn that 350 line in, we can use the intersect function. We tell it we're looking at these two lines. We want to see where they cross. So the x value there is about 5.79. So after about 5.79 years, it will have depreciated to a value of $350.